The second thing he asked the time. The second thing he asked is what? The time. The same way you will write directly the law. Okay, this is the law for time. 2 pi is constant, g is constant, mass of earth is constant. So only you care about is this number. You are searching in the problem in this number and pay attention here. R is power 3. So put R is the same in the problem, but pay attention, it is power 3. And this is G, it is a constant number, will be given in the problem. ME, constant number, will be given in the problem. Okay? So the same way. Okay, so using your calculator, okay, these two bars is under brackets, under root. Wissam Jawahir, stop writing. Okay, so using your calculator, you will get the final number. Okay, so I hope it is clear. It's only know the two laws and it is direct substitution. Okay, Abdul Rahman. Okay, now we will move to another thing. Do you have any question? Who has any question? Raise your hands. Who has a question? Khalid? Khalid Sabri. You raise your hand ahead. Okay, any other one who has a question? If you have a question, raise your hand. Wissam Jawahir. Okay. Wissam.
يا مستر بس نمبر 14 طيب يعني احنا حاولنا نحل بطريقة ثانية يعني
Number 14 of yesterday.
Yes.
Number 14, chapter 7, section 2. Okay, just wait a second. Number 14, yes.
يس أستاذ أنا حاولت أحلها بطريقة ثانية يعني H يعني الهايت ال 2.24 بلس 6.38 طلع لي نفس الإجابة 6.38 لما نجيب الراديوس بعدين لما سوينا ديفايد طلع يعني العدد أكبر من الجايدد براكتس.
مش فاهم برضه يا انت عندك الار اللي هي مين؟ الديستانس خلاص الديستانس كله the total distance okay they are between the center of earth to the satellite صح كده؟
14
okay so
14
الهايت كان كام عندك 2.25 times 10 power 5 اوكي وفي عندك الثاني الراديوس اوف ذا satellite as I remember 2.4 times 10 power 4 طيب what is the addition he said here if it is 24 kilometer larger so احنا حطينا الايه 24 زياده يعني these two numbers from the previous example يعني two numbers done these two numbers from the previous problem okay صح كده؟
yeah.
He said if يعني another satellite but it is 240 kilometer larger خلاص يبقى بتاع عملنا addition لمين؟ للنيو distance okay
okay
so what's the problem here؟
طيب هو حط ار اي كمان طيب يعني ايش؟ اتش بلس ار اي بعدين نزود ار اي كمان دحين الراديوس مو 24
كده هتخلينا نرجع نبص على البروبلم كلها بصح. يعني انت you don't understand the problem or the problem with the calculations
no I don't understand the problem يعني هذه الار
هذه الار اوكي
هو بس استخدم
هنا
اتش بلس
وسام بقول لك assume that a satellite orbits Earth 25 kilometer خلاص it is 25 kilometer okay above the surface of the Earth طبعا 25 حولناها لايه we change it into meter okay
اوكي
given the mass of Earth, okay, it is constant with radius of Earth. خلاص the distance, the total distance from the satellite to the center of Earth. يبقى عندك you have the radius, you have the height of the satellite. Okay, so you add them together. But this number 25 is given, and this is what the radius of Earth. 6.6 times 10 power 6. Okay, يبقى this is the first height here. طيب السكند height بقى in problem number 14 you have to add what? 24 kilometer. It is 24 kilometer. So when you change to meter, it will be 2.4 kilometer. طيب لما تعمل addition بقى انت عندك power 5 power 4 power 6 you have to unify the power first, then the final result will be 6.63 times 10 power 6. So here he raised it 10.4 to power 6, he raised power 5 to power 6 يعني هتبقى this number will be it's about addition of significant figure يا وسام. يعني this power to make power 6 you have to change the number 0.225. And this number to make it power 6 it will be 0.024.
طب يعني ما ينفع نخليهم زي ما هم؟
لا because you have different power channel. We talk in the significant figures خلاص how to add numbers with different powers. You have to unify the power first. Okay, you have to unify the power first. Okay, so this is the problem. Okay.
Okay.
Hope this is clear now. Come down to another. Let us start with our topic today, شباب. Our topic today is the same idea of gravitational force. Okay, the same idea of gravitational force. A free fall acceleration. We talked before free fall acceleration. What is new? The new thing that we can calculate free fall acceleration using the law of gravitational force. This law is the gravitational what force, and the Newton's second law, law F equals ma. F net equals ma, right? Everyone, it is clear? We know Newton's second law, F net equals ma, and the gravitational force, F equals gma m over r squared. I'm not asking you to know all of these calculations, just you have to know the last equation. A equals g re by square over r. Right, let's open the PowerPoint. So here, free fall acceleration, the acceleration of objects due to Earth's gravity, and again concentrate, the acceleration of object due to Earth's gravity can be found. So he is giving us another way to calculate the Earth's gravity, okay? Found by using Newton's law of universal gravitation and his second law of motion. It is given as A equals G, open brackets, R. E means what? Radius of Earth, radius of Earth. Over R, what is R? The distance between the Earth and the object. And all of these brackets is power 2. We will have an example now. The astronauts in a space shuttle are in an environment often called zero-G or weightlessness. You can see in your book this astronaut which is feel weightlessness, right? It is floating in the air. She is floating in the air. Why this happen? The gravity inside the shuttle is not zero. It is G 8.7 Newton kilogram. So there is gravity. But why does he feel weightlessness? This is the question now. Can I have? Could I have someone to answer? Ahmed Majid. Ahmed Majid.
الو
Ahmed Majid, yes.
هلا مستشفى.
Why this astronaut feel weightlessness? Yeah, she feels she has no weight. Why? Why she is floating? Inside the shuttle, the gravity is 8.7, not 0. So why she is floating? This is my question. You don't know. Okay, another one. Give me suggestion, يا أحمد. Give me suggestion يعني. وسام جوهرجي.
Yes.
Yes.
Because she is in zero gravity. She experienced.
No, zero gravity means weightlessness. Why she feel weightlessness? Why this happen? The gravity is zero? No. This state, we call it zero gravity or weightlessness, but it is not zero. The gravity actually is 8.7. But why she feels she has no weight?
Because
Who
there
can
is no
answer?
contact force on you.
Excellent, because there is no contact force. What is the importance of your contact force? When you are sitting on a chair, the contact force between you and the chairs makes you feel your weight. When you touch the earth with your feet, this contact force makes you feel your weight. Okay? But what has happened? The shuttle or the ship itself and the girl itself, both of them are flying on the air, okay, according to the Earth's of gravity. So there is no contact force. There is no contact force, okay? So this is the reason why they feel weightlessness, okay? So
Teacher,
astronauts,
what is RE?
R radius of Earth, E Earth, okay? And these are distance between the Earth and the object. We'll take an example now. So astronauts in a space shuttle are in environment often called zero-G or weightlessness type. Astronauts orbit about 400 kilometers above Earth's surface. At that distance, okay, G equal 8.0 meters per second. So G is not zero, only slightly less than on Earth's surface. So why this happen? Thus, Earth's gravitational force is certainly not zero. In the shuttle, the feeling of weightlessness is due to the lack of contact forces, not the lack of gravity. يا شباب? I hope this what is clear. So why they feel weightlessness? Because due to the lack of contact forces. Due to the lack of contact forces. Okay. Gravitational field. Gravitational field is like the magnetic field, the electric field. You know the magnet? The magnet has a field around it, right? That enables it to attract other objects, right? So the gravitational field is like this one. Abdurrahman, stop writing.
يا مستر يقولوا لك unmute.
Look, I had a topic, gravitational force. Why do you weigh less on the moon? Hey, what are you doing? It is not possible. You cannot fly on Earth. Please listen. Look, I had warned you. Now, why don't you try the same activity on the moon? There, you will weigh much less, and thus you can fly short distances. Huh? See? I was correct. Do you know why you weighed less on the moon? To understand this, we need to first learn about weight. No, not those weights. Weight is the force with which an object is pulled towards the center of the Earth or any other celestial body. This force is called the gravitational force. Greater the gravitational force exerted by the celestial body, more will be the weight of an object present on it. So, does this mean that the moon exerts less gravitational force than the Earth? Oh, bingo. You are right. But do you know why? This is because gravitational force is directly proportional to the mass of an object. Greater the mass, greater will be the gravitational force exerted by it, and thus, more will be our weight. As the moon has lesser mass than the Earth, it has a weaker gravitational pull, and hence, we weigh less on the moon. discs, which are very small magnets. And then curiously here we have a
So as you can see, the magnetic field here, it is like what? It is like the gravitational field on Earth. Okay. So the gravitational field, gravity acts over a distance. It acts between objects that are not touching or close together. Okay. Any object with mass is surrounded by a gravitational field in which another object experiences a force due to the interaction between its mass and the gravitational field G at its location. فده gravitational field. And this gravitational field يا شباب in general يعني for example I want to calculate the gravitational field of the moon, I'll use this law. I want to calculate the gravitational field of Earth اللي هي كام طبعا؟ هي this value 9.8, they used this law. If I want to calculate the gravitational field of Sun, I'll use this law. If I want to calculate the gravitational field of Mars, I will use this law. So this is general formula to calculate the gravitational field for any planet, for any object. Okay, I hope this is clear. The gravitational field is measured in Newton kilogram, which is also equal to meter per second square. طبعا we know that Earth's gravitational field ده كام 9.8 meter per second square. On Earth's surface, the strength of the gravitational field is 9.8 Newton kilogram, and its direction is toward Earth's center. Okay, so I hope it is clear. So now, here, if you want to calculate the free fall acceleration, there is another law. يبقى free fall acceleration we can calculate from the big four. I hope it is clear. يبقى we have two ways to calculate free fall acceleration. Number one, from big four. Number two, from this law. Okay? Everyone is clear? Right. Let's take some persons. Wissam Jawaharji. Can talk, Wissam, if you want.
Yeah.
Omar Sagaf. Yes, Wissam, you have any question?
Can you go to the back of the slide?
This is the first one I told. This is the second one. No, my word is here. My word is here. Free fall, it is clear. We have two ways to calculate free fall. Number one, from the big four. We talked before, right? Number
Yes.
two, from this law. Okay?
Okay.
For the other slide here, I am telling you that each planet has its own gravitational field. Each planet has its own gravitational field, right? Right. How we calculate the gravitational field of the moon by this law? How we calculate gravitational field of sun by this law? How we can calculate gravitational field of Mars, Lepton, any other planet by this law? If we use this law for Earth, we will find it is 9.8. Okay. Another one to ask. Take another. Omar Saggaf.
So the equation of that equation, the one before, we use it to find free fall?
Oh yes, we will use this equation to find free fall.
And the same force is exerted on Earth as Earth exerts on the other planet, right?
Sorry again, Omar. This one, if you want to calculate the acceleration due to gravity, Earth's gravity, خلاص. We said we have two ways. The first way قلنا by the big four. The second way now by this formula. Okay? I hope it's clear. يبقى عندنا هنا now we have two ways to calculate acceleration due to gravity or free fall. طيب. The second law is talking about what? يعني each planet يعني if we can change this Earth by what? By Mars, by Moon, Neptune, Uranus, any planet. Okay? If you want to calculate the gravitational field on this planet, what is the gravitational field on Earth? 9.8. Right, everyone? Reply.
Yeah.
Gravitational field on Earth 9.8. If we want to calculate the gravitational field on the Moon, you will use this law. If you want to calculate the gravitational field on any other planet, we will use this law.
In the rule for this rule, teacher, we use the distance, the radius of the object, or we use the distance between objects?
We will see practical now by this one. This one. Yes, this one. Look here. Here is strong asteroid, the dwarf planet Ceres has a mass. That is the mass of the planet. خلاص. That is the mass. And a radius. And pay attention, this is in kilometer. Okay. So now we have a straight up. What is the G? What is the gravitational field on the surface of Ceres? So you want to calculate gravity or gravitational field on this planet, right? Understand the question?
Yes.
Okay. So to calculate gravity on any planet, you will use this law. This is the gravitational field on the planet. What is G? Universal gravitational constant. What is M? Mass of the planet. What is R? Radius of the planet. Okay? So you have here mass of the planet 7.7 times 10 power 20. Okay, this is the mass at M. This one, M. Okay? So what is G? General universal constant. It will be given constant. Okay? What is R? A radius. R what? Is the radius of the planet. This is what? The radius. Okay? So it is 0.2 Newton kilogram. Yani if you put any object, here will come see here. How much would a 90 kilogram astronaut weigh on Ceres? يبقى هنعمل ايه يا شباب؟ زي ما كنا بنحسب عادي خالص جدا الويت اوف اني اوبجكت الاف جي ايكوال الماس تايمز الجي صح؟ on earth كنا بنعمل الماس تايمز هي كام؟ 9.8. Okay? Understand this point? If we are on earth, but now we are on this planet, and G on this planet is 0.2. So just to multiply 0.2 times light. So the weight of the person at Ceres will weigh 20 Newton.
And can we also use this law to find something that is not directly on the surface?
Not directly on the surface. Yes, you can use, but what is the R here? R will be added. Excellent, Omar. As a satellite. Excellent. Okay. Any other one? You have any question?
What will be added?
Omar asked it. If this astronaut, how would a 90 kilogram astronaut weigh on Ceres? We suppose this astronaut is standing on the surface, okay? But if the astronaut is flying on the air, what will be G? So there is another distance or another height. So you have to add to R. I hope this is clear. Like the satellite, in the problem 14, we added extra height for the second satellite. The same thing here. But just know this is the main idea. If you want to calculate gravity or gravitational field on the surface of any planet, you will use this law. G, general gravitational constant, M, mass of the planet, any planet, R, radius of the planet. I hope this is clear.
Mister, you mean like G equal GM over R2 plus RE?
Again?
You mean if it is not on the surface, you mean like add it like R2 plus RE? Like
yes,
G equal G.
Yes. If we have another R, if we have another height, we'll add it. Okay, right. The same. I have another video here. I hope you to watch.
Ask anybody around you this simple question: what is gravity? And what you probably hear is, it's something that pulls objects towards the earth, or it's a force exerted by the earth to pull objects towards it.
Now, before we get to the basics of gravitation, there is one thing I want you to understand well. Rather, there's one thing I want you to forget. Forget the fact that gravity has got to do only with the Earth and the objects close to it. That's not gravity. We'll see examples where objects are falling to the ground, and we assume that it's the only concept we need to know about gravity. Yes, of course, it's gravity that pulls the objects towards the Earth, but that's not the only thing you need to understand about gravity. So, what is gravity? Consider your screen to be the universe, and these are any two objects in the universe. They could be planets, or humans, or animals, or whatever. Just that they both have non-zero mass. In this case, both objects are pulling the other object towards each other. This object is pulling this one towards itself, and the other object is pulling this one towards itself. This attractive force between any two masses in the universe is called the gravitational force. So the gravitational force is the attractive force between any two objects with non-zero mass separated by a distance. It's not only the force that Earth uses to pull objects towards it. But yes, as all of us have Earth as our habitat, most examples we see for gravitation will relate to the Earth pulling objects towards it. But you should know that it's not the only force that explains gravitation. In the case of Earth and a human being, the Earth is one object and the human being is another. Both are pulling the other towards themselves. But why does this happen? If you do a lot of research onto what gravity really means, you will find out that gravity is not actually a force and it's just an illusion. So for now, it's enough to know that gravitational force is just the attractive force between any two objects with non-zero mass separated by a distance. After knowing the basics, you probably have many questions in mind. Does the apple fall towards the earth, or does the earth move towards the apple? If two objects always attract each other, why don't two humans get pulled towards each other? Why don't two stars collide with each other? After watching our videos based on gravitation, you will be able to answer all these questions and understand various concepts related to them. Happy learning!
يا مستر وقت خلص من زمان.
Hello?
The period finished.
I know the period there, but you don't have period now, so we lost about 10 minutes in the beginning. Okay. Any other one wants to
Yes,
talk?
Wissam.
I'll
Wissam
unmute
wants to talk.
Wissam Bassam.
يا مستر ونص صدعت لي سنة
يا
استناك
مستر
سنة شو تفك
Yeah,
مني.
Wissam, I said the ones who want to ask, raise your hand. Wissam Gawargi raised his hand.
يدي
Ahmed Majid raised his hand. Omar Sagaf raised his. I only saw 3 hands بس.
انت
خلاص؟
شايف البارتيسيبنتس يا مستر انا رافع يدي من زمان.
ايوه بعد ايه بقى؟ يعني I asked a question. Who wants to ask? I saw the hands. At this time, I asked it at this time.
انا طيب.
You didn't get anything from the discussion يعني. We only يعني they discussed everything.
المسألة في البداية ما فهمتها وقعدت أسألك ما راضي تفك ميوت بتطالع وبعدين